Good morning, Miss. My name is Sir Joshua Rogers, and today my colleagues and I will be looking at separating techniques and chemical changes. Firstly, we will be talking about four different types of separating techniques. The first one that I will be looking at is evaporation. What is evaporation? Evaporation is a process where liquid is turned to gas, leaving a solid behind. This method is commonly used when separating a solid from a liquid. Next, I will hand you over to my next colleague.
Good morning, Miss. My name is Marisha Davis, and as my colleague, Sir Joshua Rogers, we mentioned before, we are looking at the various types of separation techniques. So for me, I will be looking at centrifugation. Centrifugation is spinning a mixture at high speed to force denser particles to the bottom of whatever you're mixing it in.
Hi, good afternoon, Miss. My name is Denzel Sawyers, and I was tasked to talk about a separating technique by the name of decantation. What is decantation, you might ask? It's carefully pouring off a liquid to leave behind a solid piece or a different liquid that would have settled to the bottom.
So here you have Miss Janita Wilson. I will be talking about distillation. So first, distillation separates two liquids with different boiling points of heating them and then condensing the vapor back into liquid. Thank you.
Good afternoon, Miss. This is Sir Rogers and
Ms. Wilson.
this afternoon we are going into the practical part of our assignment, which is decantation. So before we start this practical, I want to highlight our materials and apparatus that we'll be using. First, we have our glass here with water. We have our kerosene, our beaker that we'll be using to measure the kerosene and the water, and our mixture bottle. As you can see, nothing is inside. And now I'll hand over to Ms. Wilson as she continues this practical.
Okay, so as you can see, we have our water here. We're going to pour water to 100.
Three.
Secondly, we're going to throw the water in the mixture bottle. Sorry, Josh, we're going to do so for us.
Here we have our funnel that we're using to throw our water into the bottom. Our beaker with 100 ml of water.
Next, we're going to throw our kerosene to 100 ml. Okay, so let's just check to see if it's at the direct measurements, and if I can show it a bit more.
Could we have Sir Josh just verify there again for us?
Alright. Show it a bit more?
Yes.
Okay, great.
Good afternoon, Miss. I'm back. Miss Davis here. So, Miss Wilson would have poured 100 milliliters of kerosene within this container. So, what I'm going to do is that I'm going to pour it into our mixture bottle with the water. And I'm going to leave it undisturbed to settle for 10 to 15 minutes. So I have the bottle cap here and I have a thumbtack. So what I'm going to do is bore a hole in the center of this cap. And I'm going to remove this from here. Place the cap on back. And we're going to take a piece of tape to cover the hole as it sits. Mm-hmm. Alright.
Okay, now we wait for 15 minutes. Hi, good afternoon again, Miss. As my colleagues then would have brought you to this step in our experiment, which is talking about separating techniques, which is decantation. The next step that we're about to do, we're about to take the mixture here, as you can see, and I'm going to use the conical flask in order to have this experiment be successful. First thing I have to do, I have to remove the scotch tape that was placed by my colleague in the previous clip. I have to do so carefully. Then I'm gonna, as you can see, we have the water escaping because the water would have settled to the bottom. The kerosene is on top. We're gonna wait through this process in order for the kerosene to reach at this point here. Then we will turn the bottle over. All right, let's just carry on with this process. I know you can see the water is escaping very fast. That is my trick. I will give you more in the other part of the video. Let me just move these other stuff here so that you can have a clear view of what is going on. So make sure I have to drop to eye level just to make sure that it's happening the way I want it to happen. There you have it. A successful separating technique. Here you have is no longer a mixture. Here we have pure kerosene now, and we have the water that was passed through. That process is called decantation. The two stuff that was mixed together, which is the kerosene and the water, was in this bottle, but now it's separated. And that is it. Thank you, Miss.
Okay, so this would have brought us to the end of our experiment. So now we'll be looking at all the physical changes that transpired within this experiment. So we looked at mixing, settling, and separating. Within the mixing, we mixed two different substances, kerosene and water. They didn't turn into any new liquid, they just sat next to each other. Then we have settling, when the water goes down to the bottom and the kerosene goes to the top. They were just moving because of density, and water is heavier. Lastly, we have the separating aspect. When you pour the water into jar A, the rest of the kerosene was left within the bottle. Other examples of physical changes that aligns with our experiment would be chopping wood. The wood is in small pieces, however, it is still wood. Then we have mixing salt and water. Even though you can't see the salt, it can evaporate and you can get the salt back. So what this all means is that no new substance is to be made. We still have the same things that we used.
Excellent point. Here is how chemical changes relate to your specific experiment. In this experiment, you use a metal pin to poke the hole. If that pin stays wet with the water for a very long time, it will turn orange and flake. This metal reacts with oxygen and water to create rust. Rust is a brand new substance. You cannot change that orange flake back into a shiny pin easily. Even though the procedure is a science experiment, it is a physical change because the kerosene and water just move, no new liquid is made. The water stays water as it drips into jar A. You are simply dropping the flow. If you can mix them and then pull them apart like you are doing with the jars, it is a physical change.